So for the first problem, it goes through the point -3 comma -2, goes through the point -3 comma -2, and the slope is given to be 1/2. So I want you to write an equation of a line, but then more than that, I want you to get it into standard form of the equation of a line. So now that we know the slope of this line, and we know a point that it goes through, then you should know by now that it's going to be your favorite friend, y minus y1 equals m times x minus x1, the point-slope version of the equation of a line. We've talked about it many, many times, and we've talked about where it comes from as well. So let's substitute in y minus the y value of the point that it comes through. We're going to wrap it in parentheses, equals m, which is 1/2, times x minus the x value of the point that it goes through. We have to be careful to wrap these negatives in parentheses so we don't mess up our signs. Now here, the double negative gives us y plus 2, and on the right-hand side, on the inside, it gives us x plus 3 because two negatives multiplied together give us a positive, right? The next thing we need to do is distribute the 1/2 in. So to be y plus 2 is equal to 1/2 x. Now you're going to be careful here. What you're going to get is you're going to get 1/2 times 3. Now if you remember, if you have 1/2 times 3, that's the same as 1/2 times 3 over 1. Now when you multiply fractions, you multiply the tops, which gives you 3, you multiply the bottoms, which gives you 2. So when you have 1/2 times 3, you got to make sure and not mess it up. Go over to the side and write it out, so you're going to get over here 3/2. You see what I'm saying? This is the same thing we did before, but we just have some fractions that we have to kind of keep track of as we go. Now this would be very close to the answer, but we have this 2 over here. We're going to move him to the other side by subtraction. So we're going to subtract 2. So what we're going to have on the right-hand side is 1/2 x plus 3/2 minus 2. Now notice I didn't do anything with the subtraction yet. I just subtracted 2 from the left, which kills it, and I subtracted 2 from the right. But the problem is that this thing right here is not something that a lot of people can just do in their head. I mean, I can't even really do it in my head. But we're going to go off to the side and we're going to handle that. 3/2 minus 2, right, is the same thing as 3/2 minus 2 over 1, right? That's really what it is. When you have 2, it's really 2 over 1. So what you really have, a situation here, is you need a common denominator. Now I'm going to use a common denominator of 2, which means that I can multiply this fraction by anything I want. I'm going to multiply it by 2 on the top and 2 on the bottom. I can do anything I want to it as long as I multiply or divide the top and bottom by the same number. Why do I do this? Because then it becomes 3/2 minus 4. 2 times 2 is 4, and 2 on the bottom. Now I have a common denominator. So since the common denominator is 2, it stays in the bottom, and then it's 3 minus 4. 3 minus 4, you all know, is -1. So the answer to the question, 3/2 minus 2, is -1/2. And some of you might be able to do that in your head, that's fine. But for the rest of us, we're going to have to go to off to the side and write all of it out so that we make sure and we get the correct answer. So what you really have is the slope-intercept form here. Y is equal to 1/2 x, but this whole thing becomes -1/2, so it's -1/2. This is the slope-intercept form. I could go to graph paper, I could find the y-intercept, which is -1/2, count slope, rise over run, and I could graph the line. But I want to go beyond that, and I want to write it in standard form. So in standard form, I need to move the x to the term to the other side by subtraction. So it's going to be -1/2 x plus y is equal to -1/2. Why do I do that? Because you wanted an ax plus by is equal to c. So here I subtract x from the right, so it disappears. I subtract, I'm sorry, 1/2 x. I subtract 1/2 x from the right, it disappears. And then if I do that, I have to subtract 1/2 x from the left, which brings it over to where it is here. Now technically this is standard form, but the problem is I don't like the fact that there's a negative sign in the leading term, and I don't like the fact that there's a fraction in the leading term. So I could circle this as standard form, but it's just not very pretty. So typically what you're going to do is, let me rewrite the whole line so I don't clutter up what I have. I want to ask you, what do I need to multiply this left-hand term by, specifically this term, to kill the negative and to kill the 2 in the bottom? I can multiply it by -2. And if I multiply the left-hand side of the equation by -2, that means I have to also multiply the right-hand side of the equation by -2 as well. So when I do that, the negatives are going to give me a positive, and the 2's are going to cancel. So the only thing that I'm going to have in the very first part is just an x, and then the -2 times y will be -2y. And on the right-hand side, the negative times negative will give me positive, and the 2 will cancel with the 2, so it'll really just be a 1. When you say that things cancel, they don't disappear, they divide away and they give you 1. So you really have positive from the signs, and then you have a 1. So you have x minus 2y is equal to 1. This is the standard form equation of the line given by these things. Now, if I asked you for the slope-intercept form, I would just give you this, mx plus b. If I ask you for the standard form, if you gave me this on your test, I would probably give you most credit or almost all credit because it is standard form. However, this is really what people are looking for. We don't really want negative signs in front of the x term, and we don't really want fractions, if we can help it, in front of the x term. So what you want to do is multiply things on both sides to kind of kill the things that you don't like. And as long as you do it to both sides, you're totally legal. All right, now the next equation is interesting because I'm telling you now in this next equation that the slope is 1.2. So I'm giving you a decimal slope, which is something we haven't done before. And I'm telling you that the y-intercept is negative 0.6. Negative 0.6. So you might look at this and say, this is a trick question, right? Because, you know, I've never seen a slope as a decimal, and I've never seen a y-intercept as a decimal. It's not a trick question. Usually we use fractions in algebra, but occasionally I want to throw a decimal problem in. You handle it the same way. But when you do get down to the point where you try to find standard form, I don't want to see any decimals in your standard form. So we're going to handle it the same way, but when we get down to standard form, we're going to manipulate it a little bit so it looks nicer. So what do I know? I know the slope, and I know the y-intercept. So that means I can do y is equal to mx plus b. The slope is 1.2 plus b, but b is negative, so it's really going to be negative 0.6. So this is the equation of the line. I could graph it. Here's the y-intercept. Here's the slope. I could do it. No problem. But I want to write it in standard form. So let me move this term over by subtraction. So it'll be negative 1.2x plus y equals negative 0.6. I just subtracted it from the right, subtracted it from the left. And here's where you kind of like get into a problem because you're like, okay, this is standard form. It is ax plus by is equal to c, yeah, but it's got a negative sign, which I don't like, and it's got a decimal, which I definitely don't like. The negative sign's easy to kill because you can multiply both sides by negative 1 and kill the negative sign in the front. But you might have to think for a minute on how I get rid of this. And it's not actually obvious at first what to do. But if you go off to the right-hand side of the board, let me remind you of something. The number 1.2 is the exact same thing as 12 divided by 10. Do you agree with that? Because when you divide anything by 10, all you're doing is you're taking the decimal, which is right here after the 2 in the 12, and when you divide by 10, you just move it one spot to the left, right? Similarly, 0.6 is 6 over 10, right? You know that from basic math, right? Because you move the decimal when you divide by 10, one space to the left. That's what dividing by 10 does. It moves the decimal backwards one spot. Multiplying by 10 moves the decimal one spot the other way to make the number bigger by 10. Right? Why do I tell you all this? It's because I want to rewrite this to make it easier to mess around with. Instead of 1.2, I'm going to write it as negative 12 tenths x. I know it looks weird, but this is exactly the same thing as negative 1.2, right? And then I'm going to have the y, and then I'm going to have negative. I'm going to write this as negative 6 tenths, right? Let me rewrite the whole thing one more time because I don't like to clutter up what I have. Why am I writing it like this? Because now I want to kill the negative and I want to kill any fraction that I have. So I want to multiply the left-hand side by something and the right-hand side by something to kill this. If I multiply by negative 10, what will happen? The negatives will multiply, giving me positive. The 10 will cancel with the 10 on the bottom. That will kill any fraction. And that's all I want to do. So I'm going to do that on the left, and I'm going to multiply by negative 10 on the right. So what am I going to have? The negative cancel, the 10s cancel, so it's just going to be 12x. That's all that's going to be left with this term. Then I take this and distribute it in here. It'll be negative 10 times y. And on the right-hand side, the negative times the negative will give me a positive, and the 10 will cancel with the 10, so it'll give me positive 6. So I have ax plus by equals c. So what I get at the end of the day is 12x minus 10y is 6, so ax plus by is c. So this is standard form, it's great. I could circle this and I would probably give you full credit. However, you know, like when you have fractions, right? When you have fractions, you know that 5/10 is a perfectly fine fraction. But you know this is not really a simplified fraction, right? Because I can write 5/10, I can divide top and bottom by 2, and by 5 I mean, and I will get 1/2, right? So we know these are the same, but this one looks a little different, and we know that it's not simplified. Because why is it not simplified? Because I can divide the top and bottom by the same thing, 5 in this case, and then it will simplify it to lowest kind of terms, right? We learned that stuff a long time ago. This equation is perfectly fine, but every coefficient, the 12, the -10, and the 6, I could divide this whole equation by something to simplify the whole thing down one more level. So let me rewrite it so I don't kind of mess up what I have here. What would I divide by if I wanted, if this were a fraction, if it were 12 and 10 and 6, what would I divide by? I could divide by 2, right? Or another way to say that is, instead of dividing by 2, I could multiply this guy by 1/2. Which if I did that, I would have to then multiply the right-hand side by 1/2 because I have to do it to both sides. So what is 1/2 times 12? That's the question. What is 1/2 times 12? Or what 12x would be 6x. What is 1/2 times the -10, or just 1/2 times 10? It's 5, so you have -5y. What is 1/2 times 6? It's 3. This is kind of simplified further because I can't divide every one of these numbers by something to simplify it further. So this is standard form, most simplified form. And that's what I said in the beginning of this lesson, that we were going to have more complicated problems, but they were all done the same way. The only thing is, we started with some decimals. We get down to the point where we can really like have it in standard form, but we don't like them, so we kill the decimals by rewriting them as fractions over 10 so that I can then kill them by multiplying by 10. There are probably other ways to do this. You might see yourself. I'm just showing you the way I do it, right? But then when we get down to this point, I almost circle this and I'm like, well, wait a minute. I can simplify this by dividing everything by 2, which is the same thing as multiplying both sides by 1/2. This is the most simplified. 6x minus 5y is equal to 3. The most simplified standard form version of that equation. And that's what you would circle on your test. Of course, if I were going to graph it, I wouldn't use this at all. If I was going to graph it, I'd probably use this form right here, even though it's not very pretty either. I could change these decimals if I wanted to into fractions to make it a little easier. All right, next problem. The line goes through the point 4, -3 with a slope of 1/5. I want to write an equation of a line that goes through that point with that slope, so I'm going to use the point slope form. Y minus y1 is equal to m times x minus x1. So the only point I have is this one, so y1 is going to be -3, the slope is 1/5, and x minus 4 is right here, like this. Now the double negative gives me a positive, so I have y plus 3. And on the right-hand side, I'm going to distribute the fraction in, so it's going to be 1/5 times x. And then the 1/5 times the -4, if you get confused, remember it's 1/5 times -4, I guess let me write it like this, over 1. That's what we're doing. We're multiplying this by -4, but that's -4 over 1. So we multiply the tops and we multiply the bottoms. So what you get is -4/5, like this. Now, we still have a 3 over here, which is a big problem. I want to subtract that 3 to the other side. So let me go and switch colors to break it up a little bit. If I subtract 3 here, it's just going to give me y, and I'm going to have 1/5 x. I'm going to have the -4/5 here, and I'm going to subtract 3, so I have a -3 on the right-hand side. Now, I don't know about you, but I am unable to take a -4/5 and subtract 3 in my head. I can't do it. So that's why you stop for a second on your paper. It's probably what I actually do in my I have it right here in my paper. I wish I could show you. I literally put a little thing like this to tell me that I'm working on this, and I do it over here. So what I have is -4/5 minus 3, but 3 is really 3 over 1, so I can write it as -3 over 1. Now I have a fraction subtraction, right? So how can I get a common denominator, right? I have a 5 here and I have a 1 here. Well, one way I could do it is I can multiply this fraction on the top by 5 and on the bottom by 5, which will give me a common denominator of 5. So what I'm going to get then is -4/5 minus 3 times 5 is 15, 1 times 5 is 5. So you see, this fraction is the same thing as 3 over 1, but I have a common denominator of 5. So the 5 will go on the bottom, and then I have -4 minus 15, right? -4 minus 15, that's what's on top. And what do you get there? -19. So I know it's a really crazy looking fraction, and you probably want to check your work several times because it looks weird, but this actually comes out to negative 19/5. So the actual equation of a line that you have is y is equal to 1/5 x minus, because this becomes negative 19/5. I know it's not pretty, but that's right. This is the slope-intercept form, right? This is the y-intercept, negative 19/5 with a slope of 1/5. Very shallow line. But we want to go one step further and write it in standard form. So we'll subtract this, making it negative 1/5 x plus y on the left, negative 19/5 on the right. We just subtract 1/5 x, making it disappear, subtract 1/5 x over there. Now we have the same exact thing here. I don't like the negative sign in front of, this is standard form, ax plus by is c. It is, but I don't like the negative and I don't like the 1/5. So let me rewrite everything so I don't mess up what I have here so you can see everything. Negative 19/5. And then what we're going to do is we're going to decide what can I multiply the left side by to kill the negative 1/5. I'm going to multiply by negative 5. And on the right, then, I would multiply by also negative 5 to keep things balanced. And so then what is going to happen is the negatives will cancel. Well, they'll just multiply into 1. And then the 5s will cancel. So the only thing left will be x. And then when I multiply the negative 5 here, it'll be negative 5y. And then here, the 5 cancels with the 5. The negative multiplies out here, and you'll get 19. So the answer that you get is x minus 5y is equal to 19. This is the standard form of the equation of a line. This is what you're after. It looks ugly, I mean, but it's really the exact same type of thing that we've done before. The only thing hard about it is that once we got down to this point, we had to deal with fraction and subtraction. And then once we had this, we had to deal with how to cancel the 5s and how to do the fraction multiplication over here. And that's why I always tell students that probably if I had to pick one thing that I really, really want you to remember well going into algebra is just fractions. Because if you don't understand fractions, it makes every problem hard. But if you can understand fractions and get good at them, then it will make every problem much easier. So if you're having problems with this, go back to my lessons on fractions, please, and practice them. Last problem, this line goes through 2 points. It goes through the point negative 2, 3 and negative 2, negative 3, right? Now, I'm given 2 points that this line goes through, right? And I know that in order to find the equation of a line, I need to know the slope. So I can calculate the slope here. And then we can do the point slope form just like we did before. But this problem's interesting because there's something interesting about these points that I kind of want you to see ahead of time because we'll be able to check later. It's a little bit weird. Negative 2 3 is here, and negative 2 is over here. So the x value is exactly the same. So if the x values are the same, that means that this line must actually be going up and down, vertical. So when we get through all the math, we expect a vertical line. And to show you that, usually I'm not graphing any of these things, but I'm going to do this one here. So this is x and this is y. It goes through negative 2, 3. So here's negative 2, here's 1, 2, 3, here's negative 1, 2, 3. So I'm not going to label them, but I want to show you that at negative 2, 3, negative 2 for x, 3 for y is a point right here. And negative 2, negative 3 is a point down here. So you see what I mean? This line goes through both of these points, so it's a vertical line. So we expect kind of a weird sort of equation to fall out of it, but now that we know to expect it, let's check and see. The first thing we're going to do is find the slope. Delta y over delta x. y2 minus y1 over x2 minus x1. So let's subtract these y values, negative 3 minus 3, going this direction. So then we start here, negative 2 minus this negative 2. We've got to wrap it in parentheses to make sure we don't mess that up. Now the slope then is going to be equal to what? Negative 3 minus 3 is negative 6. On the bottom, you're going to have negative 2 plus 2, because the negatives make a positive. So what you're going to get is negative 6 over, what is this? 0. Uh-oh, we're dividing by 0. You put that in a calculator, you get undefined. But I've been telling you really when you get dividing by 0, it is undefined, but you can also say that it's infinity or infinite slope. So 0 slope would be like this. Intermediate values of slope of 1 is right here. Infinite slope is straight up and down. So this slope is telling you right away that it is a vertical line, right? So because it's a vertical line, you know right away what the equation of a vertical line is. It's going to be x equals something. That's what the equation of a vertical line is. What should it be? We've already graphed it. We know all of these points go through the value x equals -2. So the answer to this equation is x is equal to -2. Because what this is saying is that no matter what the y value is, if the y value is up here, down here, anywhere, the x value is always equal to -2. Always. That's why the x value here is -2. That's why the x value here is -2. No matter any other point that I choose on this line, the x value is -2. So remember, vertical lines look like x is equal to a number. Horizontal lines look like y is equal to a number for similar reasons we've talked about before. And if you say, hey, I want it in standard form, well, this is in standard form. Because remember, the standard form is ax plus by is equal to c. But we talked about this before in the past, what you have here is ax, 1x, plus by, but b is 0. That's basically for vertical lines, b is equal to 0, which is invisible here, and then c is on the other hand side of the equal sign. So even though it doesn't quite look like it, this is already in standard form. It's just that b happens to be 0, so you don't see it. It's gone, right? But it is in standard form. So all of these problems are similar to what we've done before. There's no magic like new equation, right? It's just getting your skills practiced. So I really encourage you not to just watch me do these. I want you to get paper out. I want you to write them down, even though you just saw them, and I want you to solve them yourself. I want you to get those skills practiced. And then follow me on to the next lesson where we will continue talking about lines, and then we'll get into parallel lines and perpendicular lines and functions and equations as we move through the lessons and skills that you'll need to master algebra. Learn anything at mathandscience.com.